Hello, today we're going to talk about transformers. When electricity is produced, it is produced at very high voltages. Uh, but we normally work with lower voltages in our houses, and our devices work with much lower voltages. For example, um, in Spain, houses work with more or less 230, 240 volts. And our devices work, for example, a laptop may work with an input voltage of 19 volts, okay? And a power plant might produce electricity at the voltage of something like 14,000 volts. So as you see, um, this is the house, this is the laptop, this is the power plant, okay? So as you see, there has to be some way of stepping down those voltages and also a way of stepping up those voltages, okay? By the way, why power plants, why electricity is transported at such high voltage will be a matter of another video. Okay, so transformers are devices that either step up or step down the voltage. Okay, so there's the step up transformers and step down transformers. Step down up transformers increase voltage. We will now see how step down transformers decrease voltage. So as I said, if you look at in your house and you see the plug, the electricity plug that you have there, and you're going to connect your computer, you connect that to 230 volts, more or less. In Europe, 230, 240. But then you've got the laptop normally has a box, and then that's connected to your laptop. Okay, so that box over here, this is the transformer. And if you look below it, there's normally a sticker that tells you uh, the input and output voltages. Okay, so how does a transformer work? Okay, so you must have seen something of electromagnetism and induced electricity to understand this, but it's very easy. Okay, so we have an incoming voltage, okay, and we have here a coil. Okay, so this is what we will call the primary coil. Okay, and all this will be the primary circuit, and obviously there is uh, an incoming voltage here. Okay, the current that comes here, obviously, and that's a question that comes up in exams normally, has to be alternate current. Okay, which is the one that is produced when we produce electricity, if it's not by chemical methods. Okay, so we normally produce electricity with an alternate current, an AC electricity. Okay, so we have this primary coil. The second part of the transformer is another circuit over here. Okay, that we're going to call the secondary circuit. And obviously secondary coil, and this is the output voltage. Okay, so as electricity is flowing through the primary circuit and through the primary coil, uh, any moving current creates a magnetic field. So there is a magnetic field being created here by the coil. Okay, something like this. okay, which we design obviously to affect, as you will see now, the secondary coil, okay. So there is a magnetic field, which as always we're going to call B here. We imagine it's that direction. I haven't checked it with this. So if we do the right hand rule, um, here it is flowing outwards, downwards, inwards. Yeah, it can be. So there is a magnetic field. As the current that is being transported through the primary circuit is alternating, this magnetic field is changing. And a changing magnetic field induces on the secondary coil uh, a current, an induced current. Okay? So what is happening in the transformer is an alternating current produces a changing magnetic field which induces a current on the second circuit, on the secondary circuit. Okay? If it weren't a alternating current, it wouldn't be if it were direct current, the magnetic field would not be changing, would be fixed, would be continuous, and so there would be no induced current on the secondary circuit. So you need an alternating current for the transformer to work. Okay, and there's just another part left in the design of my transformer, and it's that the secondary coil and the primary coil are normally connected with an iron core, which I will draw here. Okay, so they are coiled around an iron core. Okay, this iron core. Why is that? Well, the iron core tries to ensure that as much that the field lines of the magnetic field affect or will go through the secondary coil as much as possible, so um, that the induced current is as efficient as possible. Okay, so basically, if we look at it quickly, we have an iron core here. We have a primary coil here, and we have a secondary coil here, and that's a transformer. Okay, this whole setup, this whole device is a transformer. Okay, so we've seen how transformer. Okay, so we've seen now how it works. An alternating current produces a changing magnetic field, which induces on the secondary coil a current. Okay, why this transformer obeys a certain formula, which is the following, and it's that the number of turns in each coil and the currents are related. How? If we get the potential difference in the primary coil divided by the number of turns in the primary coil, that's equal to the potential difference in the secondary coil divided by the number of turns in the primary coil. So that's how you relate the turns and the potential difference in the transformer, and it's the first formula that you need to understand, and it's one of the easiest that you have in physics. Okay, so for example, I'll just give you a quick example. Imagine that we have a transformer here. So we have a primary coil and a secondary coil. So we imagine we have 230 volts on the primary coil. Remember, the formula is equals. Okay, so imagine we have 230 volts here, and we want to step, for example, the electric plug in our house and we want to transform that into the 19 volts that we have on going into our laptop. Okay, so imagine we have 100 and 200 coils here. Okay, uh, in the primary coil. So we want 19 volts in our secondary coil. So how many coils uh, do I have to have in my secondary coil in order to have that voltage? Well, um, if you put ns as the subject of the equation, you clearly have 19 multiplied by 200 divided by 230. Okay, which, if we do that quickly, that gives us, so that gives us 16.5, more or less 16.5 turns. Okay, so we need 6.5 turns for in our secondary coil, and this would be a step down transformer. Okay, um, we could also do it the other way. We could have 19 volts here and 230 and do the maths that way. Okay, so the formula in a transformer is very easy. The other formula that you should learn is that the power, if there's no power loss, and ideally there shouldn't be, although in real life there is normally a power loss. But if there's no power loss, the power in the primary coil equals the power in the secondary coil, and this happens for most exercises. So if you remember the formula for power and electricity, one of them was this one. So the voltage in the primary coil equals to the times the current in the primary coil is equal to the voltage in the secondary coil times the voltage in the times the intensity in the secondary coil. Okay, so we have this other formula, which is also important when we're using power and you can use this formula to calculate if we have the voltage on each part of the transformer, and we have the intensity in one of them, we can calculate the intensity in the other. Okay, so to sum this up, transformers are devices that can step up or step down a voltage, either increase it or decrease it. They do that by inducing current from one coil to another, from the primary coil to the secondary coil. If we have in the primary coil more turns than in the secondary coil, we're going to have a step down transformer. If we have fewer turns in our primary coil and more turns in our secondary coil, we're going to have a step up transformer. You can easily see that with this formula here, where we relate the number of turns in the coil with the voltages on each part of the transformer. And ideally, in the exercises, we don't lose power from one part of the transformer to the other. So we have this other formula where the power, the voltage times the intensity in the primary equals the voltage times the intensity in the secondary coil. So I hope this helps you with the transformers.